Today we're going to begin Chapter 7 by talking about similar polygons. In similar polygons, all corresponding angles are congruent and the lengths of the corresponding sides are proportional. When we talk about the proportionality, we use the scale factor, which is the ratio of the corresponding parts. So here we have triangle ABC is similar to triangle DEF, which means that angle A is congruent to D, angle B is congruent to E, and angle C is congruent to F. Just like in congruent polygons, we list the vertices in order. It also means our sides are proportional. So side AB over side DE is equal to the ratio of BC over EF, which is equal to the ratio of CA over FD. If we want to find the scale factor, we just look at those ratios. So for example, we said AB over DE is going to give us our scale factor, or our ratio of the corresponding parts. So AB is 15, DE is 6, so the ratio or the scale factor is 5/2. And we could have tried any of these. So if we look at BC and EF, well, BC is 20, EF is 8, 20 over 8 both reduce to 5/2. And again, CA is 25 and FD is 10, and 25 over 10 also reduces to 5/2. So we can look at any of the ratios and we'll get the same scale factor. So let's just look at some examples. I want you to tell me, are these sets of polygons similar? If yes, write the similarity statement and find the scale factor. Well, if we look at our first set, they look similar, but we need to decide if the ratios, if they have a common ratio with sides. So when we look at our ratios to sides, we need to line up. Now some might ask, why do we not do 10 and 20 and 15 and 15? Well, if 15 is proportional to 15, we know that won't work. They're the same length. So we want to use 15, or the biggest or the smallest side in the 20 to 15 rectangle. We want to match it with the smallest side in the other rectangle, which is 10. So we do 10 to 15 and 15 to 20, the two smallest together and the two biggest together. Now if we look at those ratios, 10 to 15 reduces to 2/3, but 15 to 20 is 3/4. So these are not similar. Let's look at the second one. So our longest sides in the big one is 18, to our smallest side is 9. So we have 18 to 9, and then our other side is 12 to 6. Well, 12 to 6 and 18 to 9 both reduce to 2/1. So these are similar. Our scale factor is 2, or 2/1. And we will list our polygons in order. So A, B, C, D, E is similar to U, V, W, X, Y. And in this case, since we actually don't know any differently, we could also list it the reverse, U, Y, X, W, V. But we have these two polygons similar. Lastly, let's find the value of the variables if I know that the two polygons, A, B, C, D, is similar to E, F, G, H. So we are going to look and say that EH is going to be the same as AD. And we know that ratio. We have 6 to 9. So if we're going to set up a proportion, we know we're going to use a ratio of 6 to 9. And then let's solve for x first. So FG is going to be the same as BC. So 6 to 9 is the same as x to 7.5. Using cross products, I get 9x equals 45. So my x is 5. We can use the same ratio, 6 to 9, to find y. So 6 to 9 is the same as y, EF, over AB, 5. Use cross products, we get 9y equals 30, so y is 39ths, or 10/3. And that's really it for similar polygons. We're going to look at this more in depth throughout the chapter, but that's just a basic overview. If you have any questions, bring them to class.